Hello everyone. This week, let's talk about light in our building design process. And in the later portion, we will discuss on how to design shading in our buildings. The use of light is important in our building design. We recognize the form of the building primarily by the way it reflects lights. What we see is the consequence of both the quality of the physical design and the quality of light falling onto it. Let's start by asking a question on what is light. In order to understand light correctly, we first need to understand that the visible light is a form of wavelengths or photons. It is only a small portion of this range of electromagnetic wave of energy. We see only a small portion of the electromagnetic wavelengths. We call this portion a visible light spectrum. Based on the frequency of its wave, these are the range of radiation types. It is interesting to know that some other animals, such as rattlesnake or insects, are capable of seeing infrared radiation or the ultraviolet radiation by their eyes. Although we cannot see beyond visible spectrum, we can still feel infrared radiation on our skin as a form of heat. Ultraviolet radiation with somewhat shorter wavelengths cause our skin to tan or burn. Let's learn how to count and measure light. First of all, the rate at which a light source emits light energy is called a luminous flux. The rate at which a light source emits energy is analogous to the rate at which a water sprays out of a garden hose. It is important to remember that this luminous flux is the rate of the flow, and it is measured in a unit called lumens. The quantity of light a lamp emits in all directions is indicated by its lumen value. The same unit is used in both imperial and SI system. The light from a light source will illuminate a particular surface. Illuminance is a measure of how much luminous flux is spread over a given area. It is also helpful to use the analogy of water to describe the luminous concept. While the rate at which water flows out of the fixture can be compared to luminous flux of light, rate at which the water is being received on the particular area of surface explains the concept of illuminance. Illuminance is therefore equal to the number of lumens falling on each square foot. For example, when the light of one lux falls uniformly on the 1 square feet surface, the illumination of that surface is 1 foot candle per square feet, or 1 foot candle. 1 lux is defined as being equivalent to 1 lumen spread over the area of 1 square meter. Although 1 foot candle is 10.76 lux in theory, however, considering the complexity of various measurements involved, it is safe to simplify this and assume that the lux is equal to 1/10 of the foot candle. You can find some range of lux levels being achieved by different light sources here. Notice that the lux level for interior lamps range between 50 to 1000 lux. The outdoor lighting illuminance value that is being achieved by solar power is much higher than that, by at least with the factor of 10. Finally, the luminance is a photometric measure of the luminous intensity per unit area of light traveling in a given direction. It describes the amount of light that passes through, is emitted from, or is reflected from a particular area and falls within a given solid angle. The word brightness and luminance are closely related. The words brightness and luminance are closely related. The brightness of an object refers to a perception of a human observer, while the object's luminance refers to the objective measurement of a light meter. The perception of brightness is a function of object's actual luminance with the adaptation of our eyes and the brightness of adjacent objects. Although the words are interchangeable much of the time, under certain conditions, a significant discrepancy exists between what we see, which is brightness, and what light meter reads, which is luminance. Interior space of buildings are usually designed based on the required illuminance value. Working surface in the offices and classroom spaces need to be 500 and 300 lux. We only need 10 lux for parking lot at nighttime. Notice that these interior values are something that is dramatically lower than the outside condition under the sun. Now, let's think about how light interacts with materials. In the field of architecture, light and materials are mutually dependent on each other. The optical properties of the material define how it interacts with light. These are the three optical properties for every material. First is the transmittance, which shows how much light goes through the material. If the material is opaque, this value is 0. Absorptance is how much radiative energy is being absorbed by the material. The absorbed energy is converted into heat. Reflectance represents the portion that is being reflected off the surface. The three measure adds up to be 1, and these are unitless system, ranging between 1 to 0. The three optical properties that we've just discussed are related to the portion of the visible spectrum, which is here. However, the emissivity is related to the infrared radiation, which is not visible to human eye. The emissivity of the material is the measure of object's ability to emit infrared energy, and it addresses the different portion of the lighting energy. Polished metal have low emissive value. More matte or rough the surfaces, the material have higher emissivity. Emissivity is not directly related to the color of the material at all, since it is the property related to the infrared portion of the wavelengths of the energy and not related to the visible light spectrum portion. When daylighting is desired and solar heating is not, having a visible component of solar radiation pass through while heat radiation is blocked would be very advantageous. Certain spectrally selective glazing system can do that. For example, low-E glazing allow visible light to transmit while blocking certain amount of infrared radiation out. There are certain amounts of sunlight that is transmitting to the surface of the ground as a form of direct sunlight, but there are also considerable part of sunlight that is entering the Earth's atmosphere and scattered or reflected off of the cloud, aerosol, or air molecule and water vapor before it hits the Earth's surface. This part is responsible for the blue sky we see, and it is the diffuse daylight.